Today we're starting a new unit that we'll be working with really for probably a couple weeks here. And so this is sort of the introductory lesson to that. We're talking about powers and exponents. Your objective today is I can understand and apply the laws of integer exponents to simplify expressions. We're not going to get as much into that today. This is going to be more kind of an introductory thing, but we will get into that next lesson. We'll really start talking about the laws of integer exponents. So that'll make more sense kind of as we get into the next lesson. I'm going to have a few vocabulary terms to kick things off here. A product of repeated factors using an exponent and a base. That's called a power. And I'm going to explain these a little bit more here in just a second. You can just fill that in for now. In a power, the number that is the common factor, the number that's getting multiplied times itself, that's the base. And in a power, the number of times the base is used as a factor, in other words, how many times that number gets multiplied times itself, that's the exponent. So we're going to draw, and I want you to do this with me, we're going to draw kind of a little representation of this. So you guys have seen powers before. You've worked with them before, so I think once we draw this, this will be a little more familiar to you. Let's say we have a base of 7. So that's the number that's going to get multiplied times itself, and the exponent is, let's say, 3. So it'd be 7 times itself 3 times. 7 times 7 times 7 is what that means. So the whole thing is called a power. So circle that. Draw a line off the circle and write power. And then the base is it says here in power, the number that is the common factor. So it's the number that is being multiplied times itself. So I want you to draw an arrow to the 7 there and write base. And then draw another arrow to that little number up there. That's how many times it tells us that number is going to get multiplied times itself. So that's the exponent. So there's a little visual representation of each of our vocabulary terms. Power is the whole thing. The base is the number gets multiplied times itself. The exponent tells us how many times that number gets multiplied times itself. The next thing you'll see in your notes here is just a little box about reading and writing powers. So it gives us a little bit of a reference to be able to say them correctly and to understand what they mean. So 3 with a little 1 up there just means 3 to the first power. That's just 3 one time. So it's just 3. 3 with an exponent of 2, we can say 3 to the second power, or 3 squared, and that's 3 times itself twice, or 3 times 3. 3 with a little exponent of 3 there is 3 to the third power. We also could say 3 cubed for that, which is 3 times 3 times 3. And then beyond that, we have an example here of 3 to the fourth power. And we could say 3 to the fourth power, or sometimes we shorten that to just 3 to the fourth. And that's just the number times itself 4 times. And it just continues from there. And it just gives any example here. So if we could plug in anything, it'd be 3 to whatever power. So it could be 3 to the 8th power, or 3 to the 12th power, or whatever it might be. And we could just say 3 to the 8th or 3 to the 12th. And that's just how many times that number get multiplied times itself. The next thing you'll see is a little box here about the order of operations. I'm not going to spend a lot of time talking about the order of operations in this lesson. Order of operations is something you guys should have dealt with a lot already in previous years. I'll just do a quick reminder here on this, and it goes through the order that we're supposed to. So we go from left to right. You know, in a problem where there's more than one operation, the order that we're supposed to do those in. So the first thing says perform all operations within grouping symbols first. Start with the innermost grouping symbols. The grouping symbols most of the time are going to be parentheses. Okay, so usually we say parentheses first. Evaluate all powers before other operations, and sometimes people refer to this as powers. Sometimes people just say exponents. So parentheses. Then you deal with all your exponents. Then multiply and divide in order from left to right. So if there's anything left after that, you'll go from left to right, and you'll multiply or divide whatever you come to first. So multiply and divide are sort of in the same step. And then after that, the very last thing you'll do is go back, starting at the left again, going left to right, and you'll add and subtract in order from left to right. So add, subtract. So some people say PEMDAS, or they'll even say please excuse my dear Aunt Sally. If you've heard that little jingle or rhyme before, it's not really a rhyme, but just a little thing to help you remember the order of operations. Sometimes people say that to help them remember the order. So parentheses, exponents, multiply, divide, then add, subtract. So we're going to be doing some stuff today that applies to that. So flip over to the back side there, and we will do some practice problems together that have to do with exponents and kind of understanding what they are and how they work. So the first part we see, it just says write each expression using exponents. So on number 1 here, it's going to be 5 times 5. I'm just going to use this little dot here, times 5. So that's the expression, equals. If we're going to write that using exponents, the base is the number that's being multiplied times itself, so the base is 5. The exponent is the amount of times that number got multiplied times itself, so this is 5 to the third. It's not asking us to evaluate that to figure out what the final answer is. It's just asking us to write it using exponents. So this is our answer. So you can see exponents allow us to write stuff, some things at least, in a much shorter way if it's the same number being multiplied times itself. So it's a way for us to write kind of larger values in a more compact way. Number 2 is -3, and in parentheses -3, right next to each other. So if we're going to write that expression using exponents, we've got to be careful here that when we rewrite this, we do write the parentheses. This is -3 times -3, and if we don't include the parentheses with that, then the negative doesn't stay with the 3 there. So we have to include the parentheses, and it's being multiplied times itself twice. So we write that with an exponent of 2. Number 3 is 1/4 times x times x times 1/4 times x times y. On this one, we've got more than one type of base here. So we're going to look for how many times each base shows up and give it that exponent. Usually we write numbers first and then our letters in alphabetical order. So we're going to start with 1/4. And so it's 1/4 is being multiplied times itself twice. Again, we have to be careful here because in fractions you also need to put parentheses around them, because that says both the numerator and denominator gets included with this this power, with this exponent. So if we got it multiplied times itself twice, our exponent is 2. So this says the whole fraction gets that exponent 2. Otherwise, it would just be the numerator if you didn't put the fraction in parentheses. Next we have x, and x is being, so we can do times, or we could just write it right next to it to show multiplication, but I'm going to be safe here and just write my little dot for multiplication. X is being multiplied times itself 1, 2, 3 times, so x to the third, or x cubed, times y, and usually when there's just 1, we don't write an exponent of 1. We understand that if we had to write an exponent, it would be a 1, and so sometimes if we need to pull an exponent from that, for some reason, we will write an exponent of 1, but usually we don't write it if it's an exponent of 1. It's kind of like just a simpler way to write it. In math, we're all about writing things in the simplest way we can, and so it's kind of like if you did write the 1 in there, it'd be a little bit. It wouldn't be wrong. It would kind of be like if you didn't write a fraction in its simplest form or something like that. Okay. On these next ones, we're actually going to be evaluating. We're not going to do number 4 up there. We're actually going to be evaluating, which means like find the final answer. So some of these we may be allowed to use a calculator, and some of them we might not be able to. So number 5 is -6. So if you don't have your calculator, you might want to go ahead and get it real quick so that you can do the calculator ones with me. So you could stop the video and go get your calculator. Number 5 is -6 squared. And so what that means is -6 times itself twice. And since the negative is in parentheses, it really is -6 times -6. So go ahead and write what you think that is real quick. -6 times -6 is positive 36, right? Negative times a negative gives you positive, so positive 36. Number 6, you are going to be allowed to use a calculator on. It's 4 to the 4th. In other words, 4 times 4 times 4 times 4. Now you could probably do 4 times 4 and get 16. And you might even know what 16 times 4 is. But then whatever that is times 4, you might have a little more trouble with. So let's talk about how to do this on the calculator real quick. So on the calculator, go ahead and turn your calculators on there. You're going to type in your base first. And then the button to the left of the 7 and up one, this with the arrow means we're going to raise to the power of something. So that tells us that the next thing we're going to type in is going to be an exponent. So go ahead and hit that. And then we're doing to the 4th power. So 4 to the 4th. 4 times 4 times 4 times 4 is 256. So we need to know how to do these with a calculator and without them as well. Some of them are big enough that we'll need to use a calculator on them. And number 7 is 2/3 to the 4th. And remember again with fractions, we're going to put them in parentheses. We're not going to use a calculator this time. When you have a fraction with an exponent, all you do to get the new answer is you take the numerator to the 3rd power and the denominator to the 3rd power. So I think we can probably figure out what this is together here if we do 2 to the 3rd. So, or 2/3 to the 3rd, excuse me. So 2 to the 3rd would be 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So your new numerator will be 8. For the denominator, it's 3 to the 3rd. 3 times 3 is 9, and 9 times 3 is 27. So all you got to do is take the numerator and denominator to that exponent there. It just applies to both. Okay, and we're going to go ahead and skip number 8 as well and get down to numbers 9, 10, and 11. I don't think we're going to do 12 either. So we'll just do 3 on each one of these. So number 9, and the instructions for these say to evaluate each expression if A is -3 and B is 5. So we're going to write an algebraic expression, and then we're going to plug in -3 for A and plug in 5 for B. So the first one is A squared plus B to the 4th. So we're probably going, at least on some of these, we're going to use a calculator, and some of them we won't. On this one we probably will, but we need to first, before we type anything in the calculator, I want you to rewrite this with the correct things plugged in. So A is -3. It's a really good habit anytime you plug in a negative number to go ahead and put it in its own set of parentheses. So we're going to do -3 like that, because it really is -3 that's getting squared there, so you have to include the negative with that. Plus B is 5, so 5 to the 4th. Since 5 is a positive number, we don't need to write in its own set of parentheses. So let's go ahead and evaluate this. We can type it all in at once if we want to and hit equals, or we can do each part separately and do order of operations. So I'm going to go ahead and do order of operations. We would do whatever's in parentheses first, but there's really no operation to do. So the next thing is to evaluate these exponents. So I'm going to do, make sure you type in parentheses, -3 to the 2nd power, so squared, or you can either hit the squared button, or you can do raised to the 2nd power when it's just an exponent of 2. There's a kind of a shortcut button for that. So evaluate that. We knew what that was. That was going to be 9. And then 5 to the 4th, we've actually already done that today. Oh, we did 4 to the 4th. We haven't done 5 to the 4th. So 5 raised to the 4th is 625. The next thing would be to multiply or divide from left to right. We don't have any multiplying or dividing to do. And so then we would just add going from left to right. So we end up doing 9 plus 625 is 634. That's our final answer on that one. Let's do another one of these here, number 10. I have in parentheses A minus B, and all that's going to be squared. So this time we're going to do it without the calculator. And so I'm going to plug in what I have for these. So we're going to give -3 its own set of parentheses, like we said. With negative numbers, that's a good thing to do if you can get in the habit of doing that. And then B is 5, and all that gets squared. So according to order of operations, the first thing we would do is go ahead and do what's in parentheses first. And in the innermost parentheses, there's really nothing to do in here though, so we're going to do what's in these set of parentheses. So it's -3 minus 5. So they're both we can think of them as both negative. They combine together and make an even bigger negative. So we get -8 with that, and that is squared. So now it's -8 squared. If we go ahead and do -8 times -8, think about what that would be. Okay, negative times negative gives us a positive, and 8 times 8 is 64. So our final answer on that one's going to be 64. And there's no operations left to do after that, so we know we're good to go. Okay, we're about out of time, so I think we're going to go ahead and just stop there. We might do number 11 in class, or we might just go ahead and go on to the on your own problems. We'll just kind of have to see where we're at on stuff. But that gives you a little bit of an introduction to exponents, and we'll see you guys in class for the rest of this lesson.